All right. Okay. Quick review. Last time we studied the classification of pure substances into what? Elements and compounds. Okay, intermediate compounds. And then we studied some details about the elements, which are arranged orderly in a what? In a periodic table. And we look deep into the periodic table. We know what the rows are called, the columns are called, and we know the elements can be classified into metals, nonmetals, metalloids, and some elements exist, or most elements exist as a solid in their natural state, some as liquid, gas, and two as what? As liquid in their natural state. Those are for elements. And then we studied the symbols for the elements and the basic units for elements, and later on compounds are atoms, and atoms bind together to form molecules. And for those elements, if they're molecules, some exist as diatomic molecules, some exist as polyatomic molecules, and some are just what? Single atoms, monoatomic elements. And finally, before we end, last time we talked about the formula of compounds and molecules. Okay, basically we use symbols of the elements and also use subscript to indicate what? The number of the atoms for each element. Okay, each element. And then we learned the rules for naming a certain type of compound called binary covalent compound. Those binary covalent compounds are seen a lot in this chapter 1. They are compounds containing what? Two non-metal elements. Okay, and the rules are basically naming the first element followed by the stem name plus ite, and then use prefixes to indicate the number of the atoms for each element. Okay, so those are the ones we studied, and then we begin studying changes in matter. Changes can be classified into two types. Physical change, meaning during the change, there is no change of composition. There's no change of identity of the substances, and there's no new substances formed. In a chemical change, on the other hand, during the change, the composition, the identity changes, and also you have new substances formed during the change. And we use chemical equation to represent a chemical change. In a chemical equation, we use an arrow to separate substances before the change and after the change. For substances before the change, we call them reactants. For substances after the change, we call them what? Products. And we started a very important topic or fact in chemical changes. That is the law of conservation of mass. It means during a chemical change, or when you put an equation of a chemical reaction, you have to make sure before and after the change, you have the same number of atoms for what? For each element. You have 2 oxygen, you have 2 oxygen after. You have 1 sulfur, you have 1 sulfur after. And that is because in a chemical change, what happened is not the identity of the atoms, but the rearrangement of the atoms. They simply rearrange. They break the old bonds, make the new bonds. Into what? Into new molecules, into new substances. Okay? If that's the case, we call the reactions that satisfy the law of conservation of mass balanced reaction, or balanced equation. Now, if you take a look at this reaction, which is called incomplete combustion reaction of carbon, for example, if you burn wood, you're basically burning carbon. And during this reaction, incomplete combustion means oxygen is not supply limited. What you will see is a lot of smoke, a lot of soot, of course, generation, a lot of particulate matters. But if you look at this equation, we have reactants, we have products, we have the arrow, everything's fine. But what you will see that is we do not have the same number of atoms, 1, in what? On both sides of the arrow. For example, here we started with how many oxygen atoms? 2, because each oxygen is diatomic. But in the product, there's only what? 1. Okay, there's only 1 oxygen in carbon monoxide. So if an equation like this, okay, still an equation like this, we call it unbalanced. Why? Because it does not what? Satisfy what we say about the rearrangement. Because where the other atom go? We said the atoms can never be created or destroyed. They simply rearrange. So in order to make this equation balanced, okay, make this equation balanced, we have to put a number. Okay, we have to play with the number, put some number in front of the formulas. The reason we reinforce the fact of putting some number in front of it is because we can never change what? The number here. Why? Because oxygen is what? Is O2. There's no way you can change this to oxygen to what? To O1. The same, carbon monoxide is what? 1 carbon, 1 oxygen. You cannot simply put a 2 here, then we're not talking about carbon monoxide anymore. We're talking about carbon what? Dioxide. So the only thing you can change to make an unbalanced equation balanced is what? To play with the number in front of the formula. We call those numbers coefficients. So to make a reaction balanced, we call that balancing chemical equation, is simply what? You add coefficients as needed so that you satisfy what? The law of conservation of mass. Okay, if you look at what we do here is very simple because it's a simple reaction. This is 2 oxygen. So I need to make sure there's 2 oxygen here. What I can do is what? Change the coefficient of this from 1 to what? To 2. But this 2 means what? 2 of this whole carbon monoxide. If we have 2 carbon monoxide, of course I have 2 oxygen. But we also have 2 what? Carbon now. Before we only have how many carbon? 1. So in order to make carbon happy, in order to not just add 1 extra carbon, I also need add a what? 2 in front of carbon. And after that, the reaction is balanced. 2 atoms, see 2 carbon, 2 oxygen, 2 oxygen, that's what we started with. After that, they what? They bound together to make 2 molecules of what? Of carbon monoxide. And this process is called the balance process. Okay, the balance process. Now, something to keep in mind. When you balance an equation, something is always conserved. What is it? The identity of the atoms, the number of the atoms, and the mass. Later on, we're going to study the mass of these are actually balanced because what? Remember Lego, you break the part, you make a new one, you use the same thing, right? These are always conserved, but something may not be conserved. And that's nothing we need to worry about. For example, the physical state, we need to worry. If it is something is gas, it is gas. If something generates a solid, when it's a solid, it depends on reaction. And also the number of molecules doesn't have to be balanced. You see that we have what? 1 molecule and 2 atoms, right? When that was how many molecules? 2 molecules, which is fine. We start with 2 atoms and a molecule with 2 molecules. And that number doesn't have to be balanced. The only thing that has to be conserved is what? Identity and what? The number of atoms. Okay, again, because what? Because chemical equation is rearrangement of what? Atoms. Okay, rearrangement of atoms. Okay, and with that, here are 2 exercises. The first one answer is given. I think you can use that later in practice. Can you guys tell me for B, do you think the equation is balanced or not? If not, how could you simply play with the numbers to make it balanced? A, the answer is given. I want you to play with it. But B?
It's not balanced because you lose a nitrogen.
Good. Now how we can make it balanced?
Throw a 2 in front of the oxygen in the reactants, and then a 2 in front of the nitrogen dioxide.
In front of nitrogen dioxide. Okay, what you said is correct, but the logic is we're supposed to put a 2 what? In front of here first. Why? Because there's 2 nitrogen. Why do you need to make what? 2 nitrogen. Is that right? Put a 2 here. Agree?
Yes.
If I put 2 here, I make 2 nitrogen. Then how many oxygen we're talking about? 4. Does it make sense? 2 of what? O2. So it's 4. Then, how do I make 4 oxygen for the reactant? Put a 2 in front of O2. Let me put on. They don't have enough space for word. N2 O2 gives N2O. Okay, you first put a 2 in front of what?
Into O2. Oh, in NO2.
NO2. Why is that? Because I need what? 2 nitrogen. But if I put 2 in front of NO2, then oxygen number becomes what? 2 of O2, which is what? 4. 2 times 2, 4. And then I need to make sure oxygen is balanced by putting what? 2 in front of oxygen. And that's how, again, what you said is right, but that's how our logic flows is. And after that, of course, the reaction is balanced. Okay, again, these are 2 simple ones. We even don't talk about the rules. But now, let's take a look. How do we systematically balance any chemical equation? Okay, here are a few cases for to show you in this class, and then again in your test and quiz you're going to see a lot. Okay, for balancing. So first one is this equation. Okay, this reaction shows the combustion of this molecule C3H8. Okay, the name of the molecule is called propane. Okay, actually the one you burn in a grill, in a tank. Okay, propane. React with oxygen. The products are carbon dioxide and what? And water. Okay, so if I see a reaction, of course, this reaction by first glance is not balanced. Now, how do we balance it? Okay, how do we balance it? We know balance is make sure we have the same number of atoms, what? On either both sides of the atom. So technically speaking, you can start with any element first. We have how many elements we're talking about? Carbon, hydrogen, what? Oxygen. You can do any elements you want. But to make things easier, or you can less confusion in the end, we usually start with an element that is present in just one compound on each side. One compound on each side. For example, what? Carbon. Right? Carbon present on what? One compound on each side. Right? Or what? Hydrogen on what? One compound on each side. So how do we do that? I think I have a flow here. Okay, I don't need the drawing board. First, there's 3 carbon here, right? So in order to make 3 carbon, I need what? Put a 3 carbon dioxide. So that's why 3. And next, 8 hydrogen. In order to make 8 hydrogen in water, I need what? Put 4 here, because 4 times 2 is what? Is 8. 4 means what? 4 of water. That's 8. Now, after this 3 and that's 4, I got what? I got carbon and what? Hydrogen balanced. The only thing that's left behind is what? Is O. Apparently I have more oxygen here than there, so I need to count how many oxygen I'm talking about here. 3 times 2 is what? 6. 4 times 1 is 4. So 6 plus 4 is 10. How do we make 10 here? Put 5 in front of oxygen. So the balanced equation is what? 1 we don't show here is 5, 3, and what? 4. And you can always check. This is what I checked. Left, 3C. Right, 3C. Left, 8H. Right, 4 times 2, 8H. Left, 5 times 2, 10O. Right, 3 times 2 plus 4 times 1, what? 10O. Does it make sense? This is easy, right? Okay, your turn. Can you tell me? You can work on your scratch paper or computer, whatever. Can you tell me what number do we need to put? To balance this equation.
You need to put a 2 in front of the hydrogen on the right. So you have 4.
Put in front of what?
That
Water.
Yeah.
Okay, that's water. 2 in front of what? Water. Good. And
Probably 2 in front of the oxygen and the reactants.
2 in front of oxygen in the reactant. Do you agree?
Yes.
Let me see. H4. We have with oxygen again. Give CO2 and H2O. I put what? 2 in front of water, and then what? 2 in front of oxygen. Is that balanced? Double check.
Yes.
Yes or no?
Yeah.
Yes or no?
Yes.
Yes. Okay, it is balanced. 4 oxygen is what? 4 oxygen. Is that right?
Yes.
Okay, next. How about this equation?
You would need a 9 in front of the water.
Okay, let's do it again. Okay, let me change something, and then we'll do it on the board. Okay, this is a little tricky than before. Okay, this is C8H what? H18. Okay, you said what?
Put a 9 in front of the water,
9 in front of water, so 18 hydrogen, good.
and then an 8 in front of carbon dioxide.
Good, 8 in front of carbon dioxide.
And you would need
What number do I need in front of the O?
I don't know. Because,
How many oxygen
If-
here you
if-
did? How many oxygen over here?
so that'd be 16
Plus 9?
9. That's
20.
25.
16 plus 9, 20,
so 25. So how
25. Yes, you're right. No. 9 plus 16. You're right. 25. Yes. So what?
Can't really wait.
Good. 25. So how do I make 25 here? What number might multiply 2 is 12.5?
Okay.
I make 25 is what?
25.
12.1. Alright, is that right?
Mhm.
12 and a half times 2 is what?
I
25.
didn't know we could use decimals.
We don't, but I just want to, is that right?
Yes.
Yes. Technically speaking, this reaction is balanced. We're not wrong. But, like you said, because they're molecules, we do not normally use what? Fractions. So how do we solve the problem? How do we change the fraction like a path to a whole number?
Would we double everything up?
Double everything up.
Okay.
Okay, why we double everything up? Good. Because I want to double this guy. But if I double this guy, the whole thing is already what? Balanced.
Yeah.
If I double this guy, then I have to what?
Double.
I double everything. So I multiply 2 in everybody. So 12.5 becomes what?
25.
25. 8 becomes
16.
16. 9 becomes what?
18.
18. There we go. 18 water. There we go. This is the balanced equation. Does it make sense?
Just
Okay, this is how we balance an equation. Okay, again, 12.5 is fine. It's balanced. But we don't like fractions, so we what? We multiply 2 on everybody. Does it make sense? Okay, again, I think balancing these should be very simple task for this one. If now you're comfortable, you can practice less. If not, you can practice more. Right? Now, let's use these pictures to visualize some of the reactions we have done and see what is really going on in a chemical equation. Okay, this is the task in your book, I think. Okay, first is they tell you this picture shows you some solid carbon atoms, right? This picture shows you some what? Gas, oxygen molecules, right? And carbon is monoatomic, oxygen is what? Diatomic. This is the elements. And then they ask you first, draw 2 or more pictures showing the reaction between oxygen and carbon as it progresses to form carbon dioxide and carbon monoxide products. Okay, so basically showing what? Either I get carbon monoxide and what? Carbon dioxide. So this is carbon monoxide and carbon dioxide. See, I have carbon monoxide, carbon dioxide. So they can either produce this one or produce this one or both. Depends on condition, how much oxygen is supplied. Okay, that's the first, or the products. We can just draw like this picture I showed you already. But more importantly is question number 2. For each of the reaction you draw, how many products molecule might be formed from these reactants? Are there any atoms left after the reaction has gone to completion? Okay, that's more important to think about. Is, let's say, I'm making carbon monoxide. Okay, this is the reaction, only give these guys. Okay, only give carbon monoxide. Take a look at the carbon monoxide. What do we have here? Each carbon monoxide has how many carbon, how many oxygen?
1 and 1.
1 and 1, right? Now, take a look at these two pictures. For oxygen, we have how many oxygen molecules here? 5. Then how many oxygen atoms do we have before we start the reaction? How many oxygen atoms? 10, right? 5 molecule 10. Remember here, each carbon monoxide has 1 oxygen. Is that right? So holding I have 10 oxygen means what? How many carbon monoxide can I make? 10. Is that right? Why I can only make 10? Because I only have how many oxygen? 10. Is that right? Make sense? Now think about it. If I can make 10 carbon monoxide, how many carbon did I use? 10. Do we have more than 10 carbon or what?
Yes.
Yes. So that means what? If the reaction only generates carbon monoxide, this will be all used up. Is that right? Some carbon will be what?
Left over.
Will be left over. Right? Will be left over. Similarly, if we only give carbon dioxide, what do you think? How many carbon dioxide I can get? 5. Right? Because we have how many oxygen? 10. 5 carbon dioxide, we have what? 10 oxygen used up. How many carbon did we use here?
5.
Only 5. Means what? If you give carbon dioxide, more carbon will be what?
Left over.
Left over. And this further gives you some idea. Sometimes when substances react, they don't react perfectly in a matched amount like we balanced here. There is a chance that one of the substance will be what? We used up. The other ones will be what? More than we needed, called excess. Does it make sense? This is again something to think of. We don't get deep for this type of calculations. General chemistry does. But for Chem 105, I want you to have an idea. Sometimes chemical reaction run in the way one of the substances will be what? Will be used up. Some will be left over. Okay, some just like in your kitchen, you're making soup, for example. You have water, you have cheese, you have beans, etc. Right? You're gonna have use some of them all based on the recipe. You have some what? More than you needed, left over. Okay, the same idea for reactions. Okay? Next. If you recall those reactions we balanced before, 3 major, these 3. This one, and this one. Of course, they're not balanced. We balanced in class. What do you see in common? What do you see in common?
They're using the carbon and hydrogen.
They all react with what?
Carbon.
Oxygen. Is that right? The product is always what? CO2 and what? Water. Do you see that? Okay, why is that? Because these 3, C3H8, CH4, and C8H18, they are the same type of compound called hydrocarbons. Okay, called hydrocarbons. Why we call them hydrocarbons? Because what? They only contains what? C and what? H. Is that right? C something, H something. That's why we call this compound hydrocarbons. Okay, hydrocarbons. Again, N and M are subscripts, whole numbers. Now, here is a very important fact about hydrocarbons. In complete combustion of hydrocarbons, complete means you have ample supply of hydrogen, oxygen. Means what? The oxygen, the red bubbles, you have enough. You don't have to worry about do they have enough for you to combine C and H or not. You have ample supply of oxygen. If that's the case, all the C will combine with O to give you what? CO2. All the H will combine with the O to give you what? H2O. That is always will be the products for complete combustion of what? Of hydrocarbon. So that means no matter what I gave you, C something, H something, if I tell you complete combustion, then you know what? It will react with the oxygen to give you what? CO2 and what? H2O, water. Always that case. The only thing you need is what? Is to balance it. How many C? How many C here? If C is N, then you have what? N carbon dioxide here. If hydrogen is M, you need what? Divide by half because each water has what? Has 2 hydrogen. And then you, based on the number of O's to figure out how many oxygen do what? Do you need? Does it make sense? This is a very important general reaction showing complete combustion of molecule like this will always give you what? CO2 and water. Okay, CO2. Now, why we study this? Because those 3 substances we've just seen are the commonly used fuels we use daily every day. This guy, the name is called methane, is natural gas when you go cooking. If your house has natural gas, this is what you're burning every day. This C3H8 is called propane. It's the one you what? You do barbecue with. A big tank. If you go grocery, you get a big tank of propane. This one C8H18, it's called octane, is the one in your car. It's called gasoline. Okay, the gasoline is a mixture of all kinds of C8H18s. So that means what? The fuels you're burning every day, complete combustion will always produce what? CO2 and H2O. You're burning, you're producing these gases every day. But one thing is this reaction is called complete combustion. Okay, complete combustion. But in reality, especially when you're driving in your car, ample supply of oxygen is not always the case. No matter how good your car engine is, even how good your driving habit is, you always end up with not enough oxygen supply. That means these fuels, including gasoline, will have some incomplete combustion. Now, incomplete combustion will not give you always CO2 and H2. Instead, some carbon monoxide will be generated. We studied carbon monoxide. What is it? We studied in this chapter. What is a carbon monoxide?
It's one carbon monoxide.
Yes, what is it? We studied is one of the what? One of the bad gases in the atmosphere, right? In the air. It's a silent killer, right? So that means you're actually producing a lot of carbon monoxide because again, complete combustion is not always the case. It's naturally is always this ideal. We can never be this ideal when we have a combustion device, engine, stove, etc. So in order to reduce the amount of carbon monoxide, okay, carbon monoxide, especially gasoline, our vehicles has an extra device like this. Have you guys seen this before? If you look down your car next time, you will see a big box shaped near here, either around here, near the exhaust pipe, or here in the middle. It depends on how the car is manufactured. You will definitely see the big box. And this big box is called a catalytic converter. What it does is actually, before your engine exhausts the gas, including carbon monoxide, into the atmosphere, it actually helps to convert carbon monoxide into what? Into carbon dioxide. Okay, help further convert CO into CO2 before it is released to the atmosphere. So that will help reduce the amount of what? CO in the air. And besides that, besides converting CO to CO2, the catalytic converter can also reduce the amount of volatile organic compounds and also sometimes even nitrogen monoxides. before exhausting into the atmosphere. Okay, what it does is inside the catalytic converter, there are some metal catalysts, including palladium and platinum. This metal catalyst, they provide a surface for these gases, to be further oxidized by the air, again in the exhaust pipe. So when they exist into the air, they contain more the final oxidation products like CO2, water, and nitrogen. So the toxic gases, the air pollutants, will be further reduced. And that's why we call them catalytical converter, because there are a lot of catalysts inside the converter. Catalytic converter. And one of the reasons we remove lead from gasoline is because lead will intoxicate the converter, gunks it up. Of course, lead is toxic by itself too, so that's why by nowadays lead is completely phased out from gasolines as an additive. Okay? And finally, after we study reactions, let's take a look at a few reactions showing you how these bad gases are produced and generated and formed into the air. Okay, because we've talked about the bad gases, sulfur oxide, nitrogen oxide, carbon monoxide. Here, because I've seen chemical reactions, let's take a look. These reactions, how are they formed? First is sulfur oxides. Sulfur oxides. Sulfur oxides are mainly from burning coals, including coal-powered power plants and industry. They burn coal themselves to produce energy. So here is a picture showing you direct source of sulfur oxides. But here are the reactions. Okay, the first step is sulfur in the coal react with oxygen to produce sulfur dioxide. This reaction is natural balanced, right? You see that? Sulfur dioxide keeps reacting with the oxygen, which is a gas, keeps reacting with the oxygen to produce sulfur trioxide. Now this reaction is not balanced, that's why I put a 2 in front of here, 2 in front of here. And remember, from now on, when you draw a chemical equation in your quiz, in your exercise, in your homework, make sure you use arrow, subscript, and coefficient correctly. Okay, especially in your quiz. Okay, I will ask you, hey, there's arrow, there's symbol, you can choose arrow, and you can make a number into a subscript. And then sulfur trioxide, if meets moisture in the air, will form a formula called H2SO4. We call this a sulfuric acid. Okay, sulfuric acid. That is the source of acid rain. Okay, that's the source of acid rain. Okay, so these are reactions showing you the direct source of sulfur oxide. Next, these reactions showing you the direct source of nitrogen oxides. The top reaction shows the reaction between N2 and O2. Remember, in the air, the main components are what? What is the main component in the air?
Nitrogen.
Nitrogen and oxygen, right? They don't react. But at high temperature in your engine, in a furnace, in the industry, in the furnace, or in your car engine, these two gases will react to produce what? Nitrogen monoxide. Okay, nitrogen monoxide. Again, these two reactions normally don't react. That's why we have main what? Nitrogen and oxygen in the air. And NO itself is also very reactive. It will further react with oxygen in the air to produce what? Nitrogen dioxide. So these two reactions shows you why we have nitrogen oxide in the air. Okay, even burning coal itself doesn't have a lot of nitrogen. Why it also produces nitrogen oxide? Because what? In a furnace, the high temperature always promote the reaction between N2 and O2. Number three, ozone. Remember we said the bad gases, right? Sulfur oxides, nitrogen oxide. Next one is ozone. How does ozone come into the atmosphere? Ozone formation is a little different than nitrogen oxide and sulfur oxide. The reason is nitrogen oxide and sulfur oxide are naturally produced directly by reacting with nitrogen with air, oxygen, sulfur with oxygen. Ozone is a little different. Ozone formation is all because of nitrogen oxide. Under strong sunlight, nitrogen dioxide will decompose into nitrogen monoxide and active oxygen atom. The oxygen atom will be captured very fast by an oxygen molecule to give ozone. And because of these two reactions, the formation of ozone is because of what? Because of this pollutant, nitrogen oxide. We call ozone a what? Secondary pollutant. Okay, why secondary? Because it's not actually formed directly. It is formed because of what? Because of the other pollutant. Okay, so and also because ozone formation needs sunlight. Okay, sunlight. Stronger sunlight, you will see ozone concentration what? Higher. Okay, for example, as shown in this map. Okay, as shown in this map, you can see that this is the map of Southern California. I think it's the West Coast in Southern Los Angeles, yes. And you can see the ozone concentration changes during the day from 5 a.m. to 10 a.m. to 1 p.m. all the way to the night. You can see that around what? Around noon, later afternoon, the ozone concentration is highest. Why is that? Because what? Because stronger what? Sunlight. Okay, stronger sunlight. Okay, finally, we have a quick practice before some reading assignment for this whole chapter. Then we're all set for this chapter. Okay, here, very quick practice about the whole chapter, asking you hydrogen, helium, methane, these three molecules, they have all their own ppm, means their threshold. Are found in our atmosphere. Two of them are elements. Which two? Hydrogen and what? Helium, right? And the other one is compound. Number two, ask you to list 5 other substances found in the air and classify them as elements or compound. I listed it here. And we quickly go over whether they're element or compound. This one. Element or compound? Element. This one? Element. Compound. Element and what? Compound. Right? Last one. Okay, last one. Express each concentration in part A. They're all in ppm. Ask them to express the ppm as a percent. Remember we did very early, right? What is ppm? ppm is parts per what? Million. So I convert 0.54 into what? Over a million, because that's what ppm means. I translate ppm into mathematic term. And then they asked me to convert to percent, so I need to divide by what? 10,000 on both. A million divided by 10,000 becomes 100. 0.05 divided by 10,000 becomes what? 0.00054. And then I translate per 100 into what? Into percent. So I basically moved the decimal point place from where? From here to 1, 2, and 3 what? 4 places. Okay, again, these are some overview of some of the topics we studied in this chapter, but again, I hope you will be able to use these as a practice, even with the answer provided, and be able to answer the questions in your quiz and tests. Okay, in your quiz and tests. And your quiz should be open already by the end of the lecture. You will submit them before Monday, 5 p.m. Always Monday, 5 p.m. Okay, again, quiz and test, the due day is set. You have to submit by 5. Right? And the last part, only a few, but I want you to read. It's very easy reading by your book. Is some topics about indoor pollutants. Okay, indoor pollutants. We talk about outdoor pollutants a lot, and we learn the reaction based on those. We learn the chemistry based on those. But indoor pollutants, what are they? What do they include? and what are the sources of indoor pollutant, what activity would generate indoor pollutants, and these are some topics. The only thing I want to mention here is one of the most dangerous indoor pollutant is a gas called radon gas. Okay, radon gas. We'll study that in chapter 8 more. Radon is one of the gas in group 8. Okay, it is radioactive, so it will cause cancer because of its radioactivity. Okay, normally a house always has a certain level of radon, and we can use a radon meter to detect how much the radon concentrated is. And sometimes if you buy a new house, you may need to consider that if the radon concentration is too high. Even the price may be good, but you need to consider that, put that into consideration when you buy a new house. But radon is one of the main pollutant indoor, which again is cancer causing, right? So that is all about chapter 1. We studied the air. Okay, we studied the air. We studied, we studied some basic chemistry, language, concepts, and we studied the matters. How are we classifying the matters? Mixture, pure substance. How do we classify pure substances? And then we'll look at the periodic table. We studied how do we represent elements using their symbol, and how do we represent molecules and compounds using what? Formulas. And then we named some compounds, and we studied chemical equations. We balanced some chemical equations, and then we look at some equations that what? Tell us how these air pollutants are formed. And that's whole about chapter 1. A lot of info, again, like I said, it may be easy when we study during the class, but I hope you to use those as a practice, and you will get an idea when you're doing quiz for chapter 1 and see how your overview or your overview of the chapter can help you to understand and help you do the quiz and tests. Good? And by the way, quiz and tests are all timed. You can do it anytime you want before the due time, but once you open it, don't do another window, don't open another tab, just click to next, and then submit before the timer is up. Right?
So the first quiz is due on Monday?
Correct.
This coming Monday?
Yes.
All right.
Okay, let me turn it off. Okay, maybe give you a couple practice before we end early today.